Hello and welcome to Morehouse's Math Menagerie, where outliers are always welcome. Today, we're going to be talking about simulations. In a certain AP statistics class of 24 students, two of the students discover they share the same birthday. Surprised by these results, the students decide to perform a simulation to estimate the probability that a class of 24 students has at least two students with the same birthday. Assume that birthdays are randomly distributed throughout the year. We're going to ignore leap years here. Describe how you would use a random number generator to carry out this simulation. A couple of key words here before we move on. Notice it says describe. It doesn't want us to carry out a simulation. It just wants us to explain how we would do it if we were going to. Secondly, it says a random number generator. Sometimes they will specify they want you to use a random digit table, which I explained how to use in a previous video. Step 1 here would be to label each day of the year with a number from 1 to 365. Doesn't really matter the order that we number them, but it would just make sense to do it in chronological order, with January 1st being day 1 and December 31st being day 365. We're then going to use a random number generator to create a list of 24 numbers between 1 and 365. Note that we did 24 numbers because each number represents a birthday for the 24 students. If there were 30 students in the class, we would do 30 numbers, or if there were 35 students in the class, we'd do 35 numbers, and so forth. So you match up here the number of numbers to how many students are in the class. We would then record the number of students in the class who share a birthday with a fellow student. We're not concerned with when the birthdays are. We're only concerned with if any students share a common birthday. So we would record a 0 if there were no common birthdays, or 2 if 2 students had a common birthday, and so forth. We would then repeat this process a large number of times. It's important in simulations to do a large number of trials. We would divide the number of trials with 2 or more students sharing a birthday by the total number of trials. That would give us an estimated probability. The next part of the question says, the dot plot shows the number of students who share a birthday with another student in a class of 24 students in 50 trials. There may be multiple sets of matching birthdays in each simulated class. So here you can see by far the most common was that nobody shared a birthday, but there were a decent number of 2 students sharing a birthday, and even one trial where 6 people shared a birthday. They want us to explain what the dot at 5 represents. Here we would say the dot at 5 represents a trial in which 5 students in the class shared a birthday with a fellow student. Use the results of the simulation to estimate the probability that a class of 24 students has at least 2 students with the same birthday. Explain your answer. Well, since there were 50 total trials here, we would take the number of trials with 2 or more students sharing the same birthday and divide that by the total number of trials. If we counted up all those dots, we'd find out that 26 of the 50 trials had at least 2 students out of the class of 24 students having the same birthday. So according to our simulation, the probability of 2 students sharing the same birthday in the class of 24 students is 52%. Notice here that we qualified this saying according to our simulation. There is no guarantee that this 52% is the exact probability, but it should be a pretty close approximation. So we want to qualify it by saying it was found from our simulation. I will leave you with this quote by Alexander the Great. Thank you for joining us, and have a great day.